For this problem, I am given an exponential function on a closed and bounded interval for my domain. What we need to do is find relative and absolute extrema. Okay, so first thing I need to do is I need to find any critical values in, and I'm going to label this as an open interval because I'm looking on the interior of this closed and bounded interval over here. Okay, so to find critical values, I need to take the derivative of that function, which ends up being e to the x minus 2, and I set it equal to 0. So solving, I get e to the x is equal to 2, so that means x is equal to ln of 2. So think about this as being an exponential form of an equation. So this is the logarithmic form of that equation. All right. If you don't recall that from college algebra, another thing you can do is think about taking the ln of both sides. Ln of e to the x is just x because those are inverses of each other. Anyway, so this ends up being a critical value, and we need to check to make sure it's actually in that interval between -1 and 1. So if you pop ln of 2 into the calculator, you'll get approximately 0.6931. That's definitely between -1 and 1, so that is a critical value that we want to consider on that closed and bounded interval -1 to 1. All right, so my next step is to go ahead and evaluate my function at the boundaries as well as that interior critical point, critical value. Okay, so I'm going to put these as exact answers first, but I will round as well, just so I can figure out which one is largest and which one is smallest. So if you plug a -1 into the original function, so I just want to make a note here, this is into the original function f of x, not the derivative. That's really important to remember. Sorry, my handwriting is going today. Original function f of x. All right. Anyway, so if I plug a -1 into my function, I get e to the -1 minus 2 times a +1. -1, I mean. Oh, geez. Anyway, I end up getting e to the -1 plus 2. And that is approximately, let's see what I get, 2.3679. I just rounded to 4 decimal places. All right, so next, plug in ln of 2 into our function. So we'll end up getting, so again, here's our function. I'll end up getting an e to the ln of 2, right? So that ends up just being a 2, just like ln of e to the x was equal to x. And then I'll plug the ln of 2 in for the other x, and that's what I end up getting. 2 minus 2 ln of 2. Lots of 2's. And when I plug that in the calculator, I get approximately 0.6137. All right, last one. I'll end up getting e to the first power minus 2, or just e minus 2, which is approximately 0.7183. So which one is the largest? This guy. That's the largest output. So that would have to be my absolute maximum. All right. Now this one is the smallest output of those three. So that would be my absolute minimum. And then this one is just someplace in between. This last one here is just someplace in between. Okay. Now the fact that it's on a boundary. So remember, closed and bounded interval from -1 to 1. 1 is on that right boundary, so it cannot be a relative min or max. Cannot be a relative min or max. So a relative min or max only occurs within the interior. All right, so looking at the one value, ln of 2, that was in the interior, it was an absolute minimum. right? Now, because it's in the interior, it's also classified as a relative minimum as well. Now, the largest value, the absolute max, occurred on the boundary at -1. So that means it cannot be a relative maximum. So that means there is no relative maximum. Okay. The relative minimum, I'm just going to take what we wrote over here and summarize all together. So the relative minimum, I'm going to write in the form of a point. It was, which one was it? This guy. So the input is ln of 2, and the output is, take the exact one, 2 minus 2 ln of 2. Now remember, that was also the absolute minimum. So same point. Also the absolute minimum. And then we found our absolute maximum to be -1, and then make sure and take the exact value of e to the -1 plus 2. So those are all of our extrema. Okay. Now what I really want to do is I want to check this. I want to check looking at a graph, because all this is great, but it's hard to visualize what is actually going on. All right, so I graphed this on my calculator. So here is the graph, I'm sorry, the function that I put into y1. And then I chose this window down here. So notice that the x's I chose to be between -1 and 1, because that was the given interval in the first place, right? That closed and bounded interval. And then for my y's, I ended up choosing -1 to 5, because I knew that my mins and maxes would fit in there, if that makes sense. All the mins and maxes that we found were between -1 and 5. And I probably could have gone a little bit smaller, maybe used a 4 or even a 3 and gotten the whole graph in there. But this will work. It'll work. All right, so here's this lovely graph on the right side in blue. So I have the point in here. This is actually ln of 2. So remember we put that in the calculator earlier and got 0.6931. That's ln of 2. Okay. So what I did to get this is me checking my work. I hit the trace button, and then at the bottom of the screen, I got the x equals. And then I typed in ln of 2, and then the calculator just rounded for me. I hit enter, and then it spit out this y value for me, which is exactly what I got when I plugged 2 minus 2 ln of 2 into my calculator. So that's great. So we can see here that it's certainly a minimum. And just like I said before, because it's in the interior, it's both an absolute and a relative minimum. Now notice the end points. This over here is certainly an absolute, maximum, right? And if you did the same thing, if you were in trace mode, and for the x, if you popped in a -1, then the calculator would then give you that, let's see, what was it? 2.3679 and so on. So that's another way of checking to make sure that your output ended up being correct. Okay. And then remember, this guy over here cannot be a relative extrema. In this case, it would have been a maximum because it's traveling up. Cannot be a relative extrema because it is on that boundary. So one thing I want to stress is when you find all of this information from, the calculus, derivatives and all that, make sure that you graph on your graphing calculator as well, so that you can get a clear picture of what's going on and check your work that way.